All right, so now we can start. So yeah, thank you everyone for being here today for this first workshop of a series of 6 workshops on data analysis. So some little trainings for everyone. They will be happening from, well, today, which is our first session, up until the end of November. So you should have received a little flyer. Otherwise, I can share it in the chat later with all of the dates and times. And yeah, today is our first session. So an introduction to R for basic data analysis and visualization. And our guest is Joshua Culpepper, which kindly agreed to be our teacher today. So before I leave the floor to Joshua, I just wanted to quickly introduce the GSA, so the GLION Student Association. GLION is the Global Lake Ecology Observatory Network, and our mission as a student association of this network is to provide leadership, mentoring, and training opportunities for the GLION students, also encourage student networking and organize various initiatives within GLION like this one. We have different committees, among which the workshop committee, which helps organizing the Limnoseries, of which the series of workshop is part of. We also have a communication committee, which takes care of managing the GLION blog and writing posts, but also planning the networking activities at the GLION meetings and coordinating the GLION-Sec channel. We are looking for people to help with this in particular. So if you're interested, don't hesitate to contact us at the email address below. We also have a GSA poster committee, which helps putting up the abstract book for the GLION meetings. We have an incoming one in Spain in August in a month. And I just wanted to take this opportunity to thank Kirsty and Hannah, which helped prepare the abstract book for this meeting. So we are organizing those Limnoseries, and we are, of course, always looking for new speakers. So if you are interested into sharing your expertise or insights with our community, please feel free to contact us or to fill up the form, which I will also put the link in the chat afterwards. It could be an opportunity for you to get yourself or your research known by other people, by a broader audience, to practice a talk before a big conference, for instance, or to grow your network. And it's also always an opportunity for collaborations. So yeah, feel free to contact us. Past GLION Limnoseries can be found on our GLION website and our YouTube channel. This will also be recorded and put on our YouTube channel with the consent of Joshua, obviously. So yeah, you can look those up, and the other data analysis workshops will also be recorded and made available later on our YouTube channel. So now welcoming our guest, Joshua Culpepper, which is a postdoc at the Department of Biology at York University. He studied freshwater ice dynamics and the effects of climate change on lake ecosystems. He holds a PhD in hydrology from the University of Nevada, Reno in the US. And his work uses R for everything from data wrangling and visualization to remote sensing and statistical modeling of how warming winters are reshaping lake physics and water quality. And he will fortunately share his expertise with us today. So thank you, Joshua. I will now give you the floor. Stop sharing. And yeah, you can go ahead. Thank you so much.
Thank you very much. We have a lot to cover and not a ton of time. I didn't, this could be like a multi-day workshop probably, but that probably wouldn't be possible for everybody. So we're going to start with a very short just presentation on why we might be using R, kind of what we'll cover quickly, and then we'll also, if you're you might want to mute. Thank you very much. And then we'll go ahead and get into some of the actual code. And then I will make all of this available. We can send it out through the same GleonR email, and I'll send everybody the whole package so that everybody can kind of run through this code. Because there are two scripts. I think we'll kind of go through one, and then I'll leave the second one kind of as like homework. Basically, it's just plug and play, luckily. So I'll go ahead and get this going. Okay. All right. So this is, oh, sorry. Again, this is just, I called it BeginR. It's a 1 hour hands-on introduction where we're going to clean, sort of summarize and visualize some data. Um, So you can reach me at either of these emails. Feel free to ask any questions. Hopefully, we'll have some time for questions today. But if not, I'm available via email. And so when we send out the our project that we'll be looking at today, I'll have my email attached so that everybody can ask me questions. But yeah, just let me know if there's any trouble. And we're going to be looking at very super basic R. Um, so why would you want to use R? Well, it's free and open. It's always going to be free. Lots of people can contribute to it. So there's lots of different expertise going into the code. It is kind of reproducible, as I say, kind of by default. You can rerun everything with basically just a few clicks, and you'll be able to rerun all your code. You're not going to be dealing with like picking different cells and running different things on different cells. Like that can be quite, aggravating if you're using Excel for like a really big project. So that makes it a lot easier. You can use one tool kind of for everything. You're bringing in your data sets, cleaning them, consolidating them, creating a new data set, all of that can be done. You can make, publication quality figures. All the figures I make for publications are through R in general. And, there's tons of packages, including packages that deal with aquatic and environmental data. So lots of expertise on it, and you can always get lots and lots of help. The other benefit of it being free and open source. So we're going to be looking at two things today. One is like a really just foundations kind of thing, where basically we'll just be familiarizing ourselves with the RStudio environment, familiarizing ourselves with how kind of code runs, and then we'll go through and do some really basic cleaning, inspecting of data, summarizing of data, and visualization. All through R with a data set that's actually built into R, so we don't need to import it. And then the second script deals with a data set that we would need to actually import and then do some things. It's a real data set, so there's things like NA values and other issues you might run into. So that's some of the stuff we can look at in the second script if we're able to get there. If not, again, it might be kind of more of like a homework thing. So what's the difference between R and RStudio? R is kind of the engine. So it's, the thing that makes the car go. It's running everything in the background. RStudio is really something that's more for, it's more of like the dashboard, more of like all the stuff that tells you like how fast your car is going, what all you're doing, the steering wheel kind of. So it kind of, it's sort of quasi graphic user interface. It tells you about kind of what's loaded in your environment. What script is on, what stage are you at? You can use Git repository inside of RStudio to use things like GitHub, for example. And that is, I believe, something that's going to be talked about in another of these GleonR sessions. And then we're going to be using something today called an R project. So a project is really nice because it's really, like I say here, self-contained. All of your code, your data, your outputs, your visualizations, they can all go into the same folder. And if you are working with a colleague, you can basically just send them this folder and they can run everything from the get-go. They don't have to deal with like complex file paths or missing a data file that's on your computer that you had in a certain script that's not in the folder that you sent them. And it's also really nice for the future, right? So one, it's helpful for you in the future if you need to rerun something or look at some data again, but it's also useful if you are publishing a paper and then say 3 years from now, somebody emails you and asks you if they can use the data. Um, Ideally, you'd want to have that kind of data published online, but ideally, you'd also want to have your code published online. So having an R project that's, say, connected to a Git repository can be really, really helpful for that. So it makes that everything really reproducible, and then you're not having to like search your computer for a folder that you were using 4 years ago, right? And then once you get the basics down, what you can do is you can use R for basically all like a lot of your work, any kind of statistical analysis. And then there's lots of custom built packages that deal specifically with limnology. I can't recall all of the topics that are going to be covered in this series, but I imagine some of them might end up using some of these packages. For example, Lake Analyzer or GLM for some lake aquatic modeling, things like vegan for statistical analysis for things like general additive models, or you may use something like SF, which stands for simple features. That can actually allow you to use basically some of those more expensive geoprocessing programs. You can actually run those in R as well. And you can even run Google Earth Engine in R through Python. It's a little bit more complex, but you get the idea. You can do a lot of stuff in R, which is why it's good to at least learn the basics and see if it's the kind of environment you want to work in. So let's kind of just get going. I don't want to spend too much time on this here. So um, great. So this is our studio. I will quickly show you how I got here. I just had this open because we're here. So you can see that there's a folder on my desktop called BeginR tutorial, and that's the R project that I created for all of this stuff. So when we're done with this call, I'll go ahead and send this to the folks, the Glion folks, and they will send this out to you. And basically, it's a folder you can open and then just run all of the stuff we talked about today. So you'll see that there's a couple different folders inside of this tutorial. So one is your R project folder, and that R project folder, you'll just double click that and it'll basically take you here. When you first load up, I did a few things beforehand. When you first load up R, it'll tell you what version of R you're running. It'll give you some additional information. I've kind of cleared my console here, but that's some of the stuff you'll see right when you open it. And it'll open it and know where all the data is and know where all the folders are. So you can see that I have a folder called data. That's where I loaded in the data. So that's the data we will have. There's also information in the second script on where this data is located and the citation for the data. We also have, well, I guess I'll just go in order. Output, this is where one of the things we'll do in these scripts is to create new data sets and write new CSVs. So that I put those into output. And then plots is where I saved all of the different plots that we'll make in these scripts. And then source, SRC, is just basically your source code. So there's a couple different things here. I just label these by number. So there's Iris Basics. That's what we're going to start with. That's the script we're going to start with. The ice core import. That's where you'll learn how to import some lake ice data, and then you can do some different work with that. I also created this as a markdown. So if you're having some trouble, so this is a markdown script, .rmd, which it sort of works like a notebook if you've ever used like Jupyter Notebook. It basically runs the code in the script and you can kind of see the output right away, which can be really helpful. You can also run the code in different chunks. So I can show you that if we have some time. And then also there's a markdown HTML, which I'll open now. And you can see here that instead of like a coding script, like we'll see when I actually load up the script that we're going to work in, this looks more like sort of a website, and it kind of is a little easier on the eye if you're having some trouble following along in the actual scripting interface, you can actually look at this and it is telling you all the same information. It's just a little prettier, but we can't actually run the code from here. This is basically just a website. So that's something that you'll be able to run when I send along the R package. So it like shows you, oh, okay, we'll install some packages, we'll run the libraries, and we'll get all the way down like to running some plots and things like that. So you can see it all ahead of time. So that might be a way if you're getting confused inside of the script. It might be a nice way to look at it again later and be like, oh, okay, here's the notes, here's the actual lines of code. So that can be a useful way to look at it as well. Okay, so let's go ahead and jump back into R. So when you first open RStudio, you'll see this. So on the left-hand side here, you have your console. This is where kind of all of your script will run and it'll show you the output, okay? So for example, I could just do like really simple arithmetic in here, 2 plus 2, and it gives me an answer 4. I could also run actual script. This is more of what R looks like on its own, without all the fancy bits and bobs of RStudio. So, for example, I can assign X the value of 4. Okay. And then if I say X plus 2, it's giving me the answer 6. So I can do all of my like basic arithmetic. You can actually do most of your code in here. The problem is that this doesn't save anything. So every time you start R, it starts over again. So you'd lose all your code if you weren't saving it into a script. Up here is your environment, and it basically tells you what's available. What does R know is available as like a variable or a data set? And you can see that I assigned X the value of 4. So that's something that you can see here. Um, and then other things will pop up here, like when we read in data sets, it'll all show up here. Um, and then finally, in the bottom here, you get a couple different panels. Files are in here, so we can look. This is basically a file path, right? Home, desktop, beginner tutorial, and it shows you what I showed you in that other little file outside. This it basically is the same information. You can see it right there. So we're going to go into scripts, and that's where we'll pull up our scripts. Here is also where we'll see plots. They will populate here. You can export them from here, but I'll show you how to export your plots with like specific parameters. You can also go to help here, and it'll tell you some information. We'll run a line of code to give you this information here. It's about the data set we're going to work with. It's called Iris. Okay, so I'll go ahead and clear this out. This little broom is to clear things out. Um, so I'll quickly just show you how to start an R new project. So you'll just open RStudio and you'll go to File, and then you'll just click on New Project. I'm not going to save that for now. So you can do this in a couple different ways. You can create a new directory, basically like you're creating a new project, and you'll name the directory. I could call it like test or whatever, and it would save a folder to my desktop here called test, and it's where all of the code would be. So that's where the test.r project would be located. Another way to do this is to go through an existing directory. I don't really recommend this unless you're like really far into a project and you want to turn it into an R project. Then in that case, you may just go in. If everything's located in one folder, you'll choose that folder as your R project from your existing directory, or you can use version control. So this is usually what I use. So I go into Git and I have my link that I add in here, and it builds an R project for me. It'll build it always into the same folder. You can set your directory, and that's where it'll always save things when you create a new directory. But we're not going to cover this today because I think one of the sessions in November is actually going to cover how to do repositories and how to make your code really accessible and friendly to other people. So I'm not going to do this right now because I've already done it, but this is generally how you create an R project. And there are tons of really simple follow-alongs online that can help you create an R project. you can actually also just click this little guy here and it'll take you to the same thing. So I'm going to quickly show you before I inundate you with code. I'm going to quickly show you. I'll just minimize that console there. This is what a script looks like when you first open it. So you can see that I just clicked on here and I clicked on R script, right? So it created another one. You can also go through File, New File, R script. Okay, and then here is where you can see that it's numbered my line. So I can say something like library tidyverse. And so I would want to run that. And it's going to show me what I ran in the console. I already have the tidyverse loaded up, so it didn't do anything extra. But if you this was the first session of the day, it would show you everything that it loaded, right? So there is a way there's kind of how you in upload your packages, and then you can also do things like make comments. So if you just do a little hashtag, you can make a comment to yourself. And usually you'll make comments on how the whatever the code chunk works. Um, and you can give yourself information on what you were doing. Like, oh, I'm going to assign a variable. Um, right. So that's kind of like what we did when we were looking at X, assigning the variable X to 2. So you can see that it ran that in the console. And so when it did that, it populated it in the environment. So now R knows that I created a variable called 2, and I can do things like that. You can also create, an array of numbers. So this would just be me kind of like listing things out to myself. Oops, sorry. Um, okay, actually, maybe I should make this a little bit bigger. Yeah, maybe that is a little easier to see. Um, and if you're having trouble seeing things, just let me know. So here is a an array of numbers with 4 values. And so now y popped up into my environment, and now I know that there's a thing called y that's equivalent to the concatenated 1, 2, 3, 4 values. And then I can run some math. So here I can say, x plus y, and I'm going to assign that to z. Right? And now z has popped up where it added x and y. So it added my x value of 2 to my array of numbers, each one of my numbers individually, and it came up with 3, 4, 5, 6. And another way to look at that is to run it here, and you can see it in the console, 3, 4, 5, 6. Okay, so this is all some of the just super basic stuff you can do. And basically what I could do is I could uh, Control S. Oh, I've got a delay here. So what I'm doing right now is I'm just saving this in the tutorial, and then I'll save it in source, and I'll save it as test. So now if we look into our source folder, we have an R script called test. So if I were to close this out, I could always just reopen, I'm done for the day. I go out, I come back, I open my R project, and then I click on test, and it has everything that we ran. So that's the idea behind a script. So I just wanted to show you some really basic stuff on how I wrote these scripts, because the scripts are obviously more elaborate because we just have to kind of get through it in an hour. So I'm going to go ahead and clean this up, and then I'm going to go into my Iris script. Um, so you can see that obviously I've done a lot more coding in here, and you can see that I've made a lot of comments. I've made all of these comments so that hopefully, um, obviously we're going to be doing this really fast. We only have, about 30 minutes left. And so I want to make sure that you're going to be able to run this later on your own. So I'm hoping that all of these comments will help you kind of understand what's happening in each little code chunk. And speaking of, I keep saying code chunk because I create these little guys, and they are basically kind of like bookmarks. And what they allow you to do is to create a table of contents. And the way that you do this, and I'm sure that I note this later, maybe I don't. I'm sure I put this somewhere, but I'm on a Mac right now. So I'll hit Shift Command and R, and it comes up with a thing called insert section, and then you want to create a section label. So I'm just going to create a section label XXXXX just to make it stand out. And then I'm just going to call it test, test, test. Okay. And then I just hit enter, and you see this popped up. So it created this little guy, this little insert, and then it also gave me all these little dashes. The dashes essentially are the thing that notes a new kind of code chunk. You'll also see that a little arrow popped up right here on the side where the code lines are, and that can actually close some of the close that code chunk so you can make things look a little neater if you'd like. I kind of like to just have them open so it's not a big deal. And the other thing that's useful is right over here, you'll see these little horizontal bars, and it shows you the document outline. So you can see that we just inserted our new kind of little code chunk marker, our new little bookmark. And what these little horizontal bars allow you to do, oh, look, I already did this. So what these bars allow, I didn't realize that I saved that. What these little bars allow you to do is to basically move around your script without having like scroll through it, right? So if you end up on like a large script that maybe has like 500 lines, 1,000 lines, you're not going to want to scroll through the whole thing. So instead, I can just jump right down to visualize the iris data, right? Or right down to the very bottom one that I made called test, test, test. So we can see that it's really easy to move around now, right? And I can jump right back up to the top. Okay. So that's why I do that. So again, that's Shift Command R if you're on a Windows machine, Shift Control R. So really, really simple. And I'm pretty sure I noted that somewhere. I just don't see it. Okay. So we're going to go over, I'll go ahead and remove this for now. We're going to go over how to use this script. Again, some of this stuff is just little quirks of mine, like non-step basically. So I called it 0, and then install packages I called 1. So you can see that I sequentially list things. And if something's like a subcomponent of another larger bookmark, I call it star star 7A, for example, just to note that it's kind of within this whole visualization thing, because you can see that I'm showing you like a scatter plot and changing the scatter plot and making a box plot. So it's all kind of governed under that broad category of visualized data. Okay, so yeah, you'll open the beginner tutorial project to generally run this. And then we can run one line of script at a time. You can also just hit Control A and Control Enter, and it'll run the entire script all at once. You could also hit this Run button, and it'll run your script. Um, or you can highlight certain sections and run those, you know. So there's all sorts of different ways to do it. But basically, this is basically just like a point and click. We're just running through the script. Okay, so I'll close these as we finish them, okay? So first we'll install packages. So you can see that I don't have any code in this section. It's because I commented it out. Um, so if you hit Shift Command or Shift Control and C, you can comment whole sections, right? So if I were to highlight everything and hit Shift Command C, it would comment that whole section. Oops. I don't need to do that because it's already a comment, but that's just the idea. And then here, we're installing a couple different packages that we'll use. Tidyverse, Janitor, and here. So Tidyverse is a big group of functions that help you basically clean and visualize data. Janitor is something that helps you clean up names in a data frame. And here is something that directs you on where you are, basically. So if you hadn't run those already, this is the code you would run, and it'll install all those packages for you so that you can then load them and use all of the arguments that are inside of that package, all the functions that are inside the package. So anytime you want to use a new package that isn't in your R environment yet, you're going to have to run this install. Another way to do it is to go over to packages and you can install this way. And then you can like look up a package. Like if I were to look up tidyverse in here, it finds it and then I can install it. It's already installed, so it won't do anything. Um, but that's the idea. You can also look for updates there. Okay, so I'm going to comment that back out. Again, I hit Shift Command C and it commented out that section. Okay. Then libraries. So libraries are what you use to actually run all the functions and all the stuff that's in R that's not loaded in base R when you just turn it on. You can see that I didn't load any specific libraries to do arithmetic. I was able to just do that, right? We saw the outcome of all those. Speaking of which, I'll go ahead and clean this up. You can see a little broom handle there. Yeah, I want to get rid of that stuff. Um, Okay, so to run everything, we will need, so you can see I just kind of highlighted these three lines and I'm going to hit Command and Enter. I've already loaded these, so it's not doing anything extra. It's just saying like, oh, okay, hey, you loaded all these into your console, right? Um, so again, a collection of packages for your data work. It includes things like dplyr, which is manipulation, data manipulation, ggplot2, which is plots, and that's mostly what we'll be using today. I'll show you some other functions as well. Janitor helps you clean up your data, um, and I'll show you that in a moment. And then here allows you to know kind of what R can see, essentially. Like, can R see the data that I put into my files, right? So if I were to type here, hit Control and Enter, it comes up with my file path. So because I loaded this project, it's like, okay, we're in your computer, users, my name, desktop, and then we're in the beginner tutorial. Um, it looks like there are some comments. Um, I'm not sure. Okay, this is just from Glenn. Okay, cool. Um, yeah, hopefully someone can just let me know if there are like questions in the comments or something like that. Yeah, but if you run here, it shows you where to go. And then here also allows you to do things like save data. So I could be like, okay, in my output folder, I want to put a CSV file. So it knows to look into this environment, go into the output folder, and then save something called test.csv. And I'll show you how to do that at the end of this. Okay, cool. So there we go. We've loaded our libraries. So now we're actually ready to work. Normally, this is the step where I would import data, right? We're not going to import a folder at the moment or like a separate file, a CSV file or an Excel file or anything like that. We're going to use a data set that's already built into R because I wanted to try to avoid any kind of like big issues that you might have on your initial foray into R, right? So a way that you can learn about Iris or any function for that matter is to put a question mark in front of the thing you're interested in, right? So if I run that, it pulls up in my help window. I'm going to enlarge that a little bit so you can see it. So Edgar Anderson's Iris data set. So this is kind of a famous data set. I also showed it to you because when you're looking up tutorials online, often people will use this data set to do things like data manipulation. MT cars is another one of those that's built into R that people often use to illustrate as like an illustrative example. It's also helpful when you are asking questions on websites like Stack Exchange, where you can get a lot of information about code. You can do things like use the Iris dataset or the MT cards dataset to give a working example of your problem so that you can show people exactly the issue you're running into, and then they can help you fix it using the Iris dataset, and then you can transplant that into your real problem. So it also gives you things like the citation of the data and where it's been used. It also gives you some examples on how to use it. So this is another way to learn code. When you actually use functions and use packages, the writers of those packages often give you a bunch of illustrations on how the different functions work. So that's a really useful way to figure out a problem before having to go to the internet or a colleague to learn how to use a function or learn what kind of issue you're running into. Okay, make that smaller again. But that's the help window. So very helpful. So for example, we just learned about the here function. If I were to put question mark here, it pops up with that, and you can see it describes the function, it shows you some of the details, and then it also gives you some information on how it works. So again, super useful. I use it daily, essentially. I'm gonna go ahead and comment that out again. So now I'm going to make a data frame. We can just call iris, but this is kind of an example of how you make a data frame. You've seen that I've used this arrow a couple times. This basically just says I'm assigning this to this, right? So the point goes in, the arrow goes in the direction of what's being assigned to what, right? So if I run this, look into the environment section, and we'll see what happens. Cool. So now we see that in the environment, something popped up. It's called iris data. And we can see that it has 150 observations of 5 variables. You can also see that there's a little arrow here. So if you click that arrow, it tells you what's inside of that data set. And this can work for lists of lists and vectors and all sorts of things. So often we'll be working with data frames, right? Which is kind of like when you're just looking at an Excel file or a CSV file, you'll have like columns with rows, right? And the columns will have names. So this is what you're seeing. You're seeing those column names. So this is the 5 variables: sepal length, sepal width, petal width, and species. And we can see that it has the lengths and widths as numbers, and it has the species as factors. So factors are basically like organized groups with levels. So we can see that there are 3 different types of levels. But we can see that this isn't super useful. I mean, it cuts off, we can't see all the data. So what are some of the other ways that we can look at data? Okay, well, I'm going to clear this out first. So we have just kind of a blank console again. And I'm just going to hit iris data. That's what we just loaded into the environment. And you can see that there's 150 rows here. And you can see that there's 5 rows. It numbers your rows, so this isn't actually a column within your data set. Your column starts here. So you can see that there are 5 columns, 4 are numbers, and 1 is a word, a character, like it's not technically a character, but a factor. So this isn't super helpful because like what if your data set was really long, like thousands of rows. I wouldn't want to like scroll up to the top to see what was at the top. So instead, I'll go ahead and clear this out and I'll hit head of iris. So what that gives you is the first 6 rows. So it gives you a first easy glimpse at your data in your console. So again, you can see the same exact information that we saw in our environment. So sepal length, sepal width, blah, species. Okay. We can do the same thing, but with the bottom of the data set in tail. So tail's giving us the same information. It's just new. This summary tab is new in the most recent version of RStudio. So it gives you basically kind of a distribution of your data, which is pretty useful. It does like an initial little bit of information for you, so that can be useful for people. And again, this is kind of like looking at a CSV when you do that. And you can see that I just clicked on the data over here. So there is some graphic user interface in RStudio, but you can also see that in the console, in the background, rran view iris dataset. So if you were to type in that command, it brings up this window with your data. Okay. Um, and then I'm going to clear this out so we can get some more information here. STR stands for structure, and it tells you some of this information again. It basically gives you what's in your environment. I know you're thinking like, if I can see it in the environment, why would I care about putting it out here? Again, this is just all different ways to think about how your initial data structure and what you might want to do to, for example, clean it up. Glimpse is sort of the tidy version of structure, and it gives you the same information in a slightly different format. So it specifically tells you rows and columns. That can be useful if you're not used to the row column distinction, or observations versus variables, right? So it gives you that information outright. It's saying double here. This is basically just telling you that it's numeric. And then FCT is factor, and then it gives you the factors. Again, so it's the same information, it's just another slightly different way to look at it. Okay. So I'm going to clear that up. So that's all the different ways we can look at the data. So that's everything that I put into the import data, right? You read it in, you figure out what it looks like, and then you can start to do some data manipulation and data analysis and data cleaning. Um, so again, I know we already ran names, but I'm showing this because there's a lot of different ways, and this is one of the versions of cleaning your data that's really useful. For example, if instead of let's say, because it's written like this, right? sepal dot length, right? I don't really want to have under lowercase and uppercase and periods and all of those things. And then let's say you got a data set, somebody put together a data set and there's like a space in it, right? The column had a space in the Excel file. But what if that space was two spaces? You can run into all these problems where you're trying to read in data and it keeps throwing errors and you don't know what the errors are. And it's just because of something like there's an extra space. Um, or, there was a space instead of a period, or there was a period, or you didn't put in the right lowercase, uppercase. So I don't particularly like dealing with that, right? So I'm going to do this function that we loaded that janitor package, and it has a function called clean names. So I'm going to assign the function clean names to iris data, right? So we're doing something to the data set and assigning it the same name. Maybe you could assign it a different name. You could say like iris data 2 if you wanted to preserve the original iris data set. I don't really feel that that's necessary. So I'm just going to go ahead and run this. And then you can see in the environment that they all changed, right? So let's go ahead and look at that this summary here, and we can see that it says sepal underscore length, and now everything is lowercase. So now everything is a lot, I think, more typing friendly, and you're less likely to you're not like at all now likely to run into issues with spaces or apostrophes or any kind of like weird notation. It just helps you deal with that. And then again, we can look at those names and see that we kind of clean this up. And I much prefer how it looks now compared to how it did look. Again, some of these are my preferences. This is called snake case, and I prefer to write that way. Some people prefer something called camel case, and that would look more like this. So if I had this and I put sepal length. So the first letter of the second word is a uppercase. I just don't prefer to type that way. Some people do. I prefer the snake case version. Okay. Um, great. So we cleaned up this data. This data was very easy to clean. As you can see, you're not going to be so lucky in your own data, I imagine. So now we're just going to do a couple different things. We're going to summarize the data. All right. So what this did is it gave us a summary, basically like what you'd get out of a box plot. It gives you the mean and the median, it gives you the min and the max, and the first and third quartiles. So summary did that for all of the individual columns. You'll recall that we had three species. Again, species had three levels. So it actually summarized everything. This is just the entire data set. So I'll show you in a moment how to look at that individually. So again, here are all the individual functions that summary gives you kind of on its own, but you might want to look at them by themselves, right? So the mean, the median, the standard deviation, and the range. So I did this all for sepal length, so we can see 5.843, and we look up at the sepal length, and it was 5.843 for the mean. So that's how you can get all of these individually. You can also get counts for the individual species. Table helps you tabulate your data and understand, what all is in, like for example, the species. So there's 50 of each. Remember that we have 150 observations, so we have 50 observations for each individual species. So that's some of the initial information that you can learn just like at a glance at your data set. And some of this might be really, really useful when you start to try to explain your data set to other people. Let's say you have like water temperature data. Someone might want to know like, oh, you're in this latitude, what's your mean temperature? They might want to know if it's colder than the lakes in their region, for example. So this is some of the ways that you can get that information, how variable your data set is, what the range is, all of that. And so now we're coming up to the pipe operator. So the shorthand way to write this is shift control or command, shift command and M, and it gives you this pipe operator. And what the pipe operator is basically saying is, um, I tell you to kind of read it as and then. I want you to take the iris data set and then I want you to do something to it, right? So it basically allows you like a really nice readable workflow. And you can see not everyone does this. I prefer to do things this way. So I will show you what all this does, and then I'll explain why I wrote everything on its own individual line. So I'm creating a new data set called species summary, okay? And I'm assigning it, and it's coming from our iris data, okay? So we already created this data set. We already looked at it. We know some of the stuff. We know that there are individual species. So I'm going to take the iris data set and I'm going to pipe it to say like, okay, we're going to do something to it. And we're first going to group it by species. So what this is telling us to do is to say basically, okay, I want you to do stuff to the data set, but I want you to do it to the groups individually. I don't want you to do it to everything as a whole. Remember that when we looked at our summary data, it did it to the entire data set. So instead, I want that summary data, but I want to look at it by individual groups. So we're going to use summarize. You can also spell this as summarize. You can use either one. I don't know why, but in the when I'm writing code for some reason, I write the British spelling, and I don't know why. But you can also do summarize. They're identical. And again, you can put question mark summarize, and it'll tell you more about that. So n, I want to know the count. So the function n does that for me. I want to know the mean sepal length. So I'm saying mean sepal length. There's no missing values, so I'm not dealing with any NAs. So I'm not having to deal with any of that stuff. That's why I use this data set initially, because I don't want to overcomplicate the situation. And then we're also just doing standard deviation of sepal length, the mean of petal length, and the mean of petal width. Okay, so this is just like a sampling of what you can do. Okay, I'm gonna shrink that again. I'll go ahead and run this. Okay, so we can see that there's 3 observations of 6 variables. Okay, so what are those 6 variables? Let's go ahead and take a look. So we have our species, and then we have the 5 that we created: the count, the mean sepal length, the standard deviation of sepal length, the mean petal length, and the mean petal width. So you can see that there's 3 rows because there's all of those observations for each individual species: the Setosa, the versicolor, and the virginica. Okay, so that's how we can create a new data frame and how we use that pipe operator. We take something and then we do something to it, and then we do something else to it, and then we do something else to it. So I could then go and do something else. I could say, oh, I want to do this, but I want to filter certain values. So we'll look a little bit more into that. You can also just print that into your environment. I kind of prefer to look at the full data frame. Okay, so now some basic data manipulation with the dplyr. So it gives you a set of verbs for reshaping your data, and below I think are the ones you will most commonly use. So there's select, that allows you to select specific columns. There's filter, that allows you to choose rows that meet some condition. Mutate allows you to create a new column, or to change a column. And then arrange allows you to sort rows. Arrange by default will sort from smallest to largest, or in alphabetical order or whatever. And then if you can add certain things to it to flip that arrangement. And summarize, we just saw it kind of collapses big data frames into something more small and manageable. Okay, So first we're going to do a select. I'm going to do iris data, but I only want to select, and remember, select is just columns. So remember, originally we have 5 variables in iris data, but if I select just those 3, it reshapes that data frame into just 3 individual columns. So I've limited the scope. That might be useful if you have like some columns that you're in your data frame that you're not going to be analyzing. Like, I don't know, for example, I use mini dot loggers to measure temperature and dissolved oxygen in lakes, and it has like a battery column to tell you how healthy the battery is. I'm not going to do anything with that, so I just filter. I select it out. And then filter allows us to select individual rows. So you'll recall that we have 50 observations of each species. So if I filter the species to just Setosa, it shrinks that data frame down to 50 rows. But we have all of the original columns. You can see there because I didn't change the select version. I could combine select and filter, right? So that we could look at just Setosa, but only the sepal length and the sepal width, right? This little double equal sign is basically saying equal to, right? It's saying is exactly, basically, is exactly this vector. If I were to get rid of one of them and tried to run it, it would give you an error in filter. And it actually is smart enough to know that you just messed up. This usually means that you've used equal instead of a double equal sign. Is this what you meant? So some of the things are, some of the error signs are clever enough to tell you what you did wrong, and then some of them are not. Here, I'm showing you that we can also do things by some kind of mathematical principle, right? I want to only look at sepal length that's greater than 6. So 61 observations met that at least greater than 6, that condition. We can also use and or. So this is an and then the flat line is an or. Um, so yeah, we can go, I want the species to be equal to Virginica, and I want the petal length to be greater than 6. Okay. Um, and then finally, mutate is a way that you can add a new column. So I'm creating a new column and I'm calling it sepal area, and I'm multiplying the sepal length by the sepal width. Um, just to note, I'm not a botanist, and I'm sure that this is not a thing that they do unless you run into like the flower that is a rectangle, apparently. But you get the idea. I just wanted to create a new column, and you can see that I created a new column called called sepal area. So instead of just 5 variables, there's now 6 variables. And then we can arrange things, and it'll arrange these based on the sepal length. So it'll start with the largest. So I could, for example, do this and then type in head, and then we can just see the top 6, right? So um, sepal length, yeah. So 7.9. So it's going with the largest first instead of the smallest first because I added the descending um, condition. And then I'm going to create a new data frame and I'm going to combine some of the stuff that we just did, right? So I'm taking iris data, I'm mutating it, I'm filtering it, I'm arranging it, and I'm just selecting a couple different columns. And then we can look and see that that's a new one. We can also click on the new data frame that I got, and we can see that I arranged that by the largest sepal area to the smallest. And we can see that Virginica, for example, had the largest sepal area. That might be something that's useful for you when you're actually looking at your own data set, like, oh, which of these lakes is the deepest or whatever. And finally, we're going to get into some basic visualizations. So here we're just looking at a basic scatter plot, and I'm going to do a couple different things to it. So ggplot is really useful because it stacks basically layers. And so we have the ggplot is like the baseline, what data are we using, and like what's the x and y variable, and that goes into your aesthetics. Then you add things on top of it. So it's kind of like layered on top of it. And whatever's on top is what's going to show up last. So if you put a point and then a line will show up on top of that point. So basically it's layered in that way. And so what we're doing is we're creating a thing called iris plot. We're using ggplot. We're using our iris data. That's our original data frame. We're not going to use the manipulated data frames. And our aesthetics is going to be X. So on the X axis, we're going to have sepal length. On the Y axis, we're going to have sepal width. And I added something called color by species. And we'll see what that does. I also increased the size of the geometry. I made the points a geometry. So I'll zoom in on this really quick. And we can see that now, because I added that color by species, it added a legend and it made each individual species a different color. So we can see that, the Setosa looks a bit different than the versicolor and Virginica, which are, they're kind of the same. The Virginica has a longer sepal length, but the Setosa has the longest sepal width or the largest sepal width. Now, I don't love how that looks. I don't really like the gray background, for example. And I'm going to change up some of how I don't like that it's just using the raw column names. I'd rather that look a bit different. If I wanted to like publish this in a paper, I want it to look a bit more professional. So we're doing the same exact stuff. This is exactly what we did last time, but now we're adding a couple extra functions. So theme minimal is going to make the background white instead of gray, but we're going to leave in those lines. You can also try theme classic, which removes the lines as well. We're going to rename some of the labels. So I'm going to give it a title, the sepal width by the sepal length. I'm going to give it on the X axis, sepal length with its measurement in centimeters, and then sepal width in centimeters. And then the color, I'm going to use an uppercase for species. Okay, so let's go ahead and run that. And, I'm calling this improved. I think it looks better, but it may not be up to your, aesthetic qualities. So you'll want to keep messing around with it until you're really happy with it. One thing to note is that red and green aren't super colorblind friendly, right? A lot of people won't be able to read your graph effectively if they have any kind of uh, color vision deficiency. I added a link in here where you can go to learn more about different kind of palettes that are better for people with any kind of color vision deficiency. And so we're using the same exact code again, but I'm adding something called Scale Color Viridis, and that is a colorblind friendly palette. Um, you can see, remember last time I put color and then species. Um, you can also change the legend name in the actual call for the color. Okay, so let's go ahead and run that and see what that looks like. So we can see that the colors are quite different. Okay. So now we have a dark purple instead of a whatever it was, green, and we have like a teal color instead of a red, and we have a yellow. Maybe you don't like the yellow. Maybe you want that to be a different color. You can go in and use your question mark, scale, color, viridis. You notice that I used D. D stands for discrete because we have specific levels and we can go ahead and run that. And then we will see all of the helpful information. So there's a lot of arguments within this function that I didn't use. So for example, end equals 1, that's what's leading to that yellow color. So I can put end equals 0.8 because I can see that the range is from 0 to 1. And let's run that. And you can see that instead of yellow, it's like a green now. So there's lots of different stuff you can do to make your plots look different, okay? And you can learn all about those using that question mark. Now let's go ahead and do a box plot. We're doing basically the same thing, but instead of a geom point, I'm using a box plot geometry. Geom stands for geometry. Um, Here, I'll have to have species on the x-axis, right? Because you wouldn't want to have just a list of numbers. That wouldn't make a lot of sense. But everything else is basically the same, and I've removed the legend position because I don't want there to be a legend. And you can see that, oh, we've made a box plot. That's nice. Again, we're running into color issues. We didn't have to fill this, right? But it's just for kind of visualization purposes. So we can see that these look pretty different. That's a nice visualization of some of the information we learned when we created our summary data set. Also, I created a time series plot. There was no time element in this data, so I made up a time element. I just want to note that like you wouldn't be able to use this. This is completely fake. This is just for illustration purposes. So I created an iris time series where I basically just created a sample date and had it run through. So each of the kind of like pretending like you were measuring the petal lengths of these flowers over time instead of just measuring a bunch of different ones, which I think is what you did instead. So here you can see that there's now a sample date that I've added in that has a date format. Often we're using dates time series work in especially in limnology. So I just wanted to make sure that we covered that quickly. So we're using all the same arguments. I'm using a line instead of a point this time, but you notice that I stacked the point on top of the line so that where the line kind of zigs and zags, there'll be a point on top of that rather than having to see the line kind of change shape. Again, just making some additional notes and then running it with the minimal, and we'll see how that looks. Great. So now we can see how it might look as a time series. Again, fake data, but we're using the real actual observations that he made, but I've added in a time element. And we can see that they kind of stack on top of each other. Um, you know, if this were something like if you were actually measuring plants, they may be like growing through time, right? Or shrinking through time if they're like senescing or whatever. Great. And now what we can do is we can save our work. So here is where that function I talked about earlier here comes into play. If you hadn't yet created a plot folder, this would do it for you. You would just have to note that's what I want it to do. So it's saying look for a folder called plot and save the plot, iris plot, the original plot we made, as irisplot.png. All right, so it's calling this plot and it's saving it. And then it's giving it a width of 7, height of 5. You can also say units. So if you want to do units equals, say, inches, you could do it that way. And then DPI is dots per inch. Most journals want you to have a DPI of at least 300. And they usually don't want you to be like above 5 or 600. You're not getting much after 300. So, that's probably what you want to save it as. And I'll go ahead and show you what that looks like. So I have my plots. So let's look at that original iris plot. There we go. You can see that when I saved it with a DPI of 300, all of the lines are quite a bit smoother. The text looks a bit better, and you can see that I saved it with a specific specification of size rather than me being able to kind of line the size up in different ways. Let's go ahead and look up the when we changed the colors. So this is what that color change plot looks like actually saved. So that's saved into your R plot. So if you sent this to a colleague, they wouldn't even have to run the code. They would just see the plots provided you saved your R file like this. Great. So all of that is just there. And then, yeah, so here's what you learned. You loaded packages with library. You inspected your data with some different functions. You did some cleaning and summarizing. You learned how to reshape your data using things like select and filter and mutate. And then we built some plots using ggplot. And then we saved the plots and tables to files. Okay. Um, oh yeah, did I not show you how to say that's the time series plot, sepal length? Okay, yeah. So write CSV is what we did to save the data set we created, the summary data set we created. So I created a folder called output and I saved it as species summary.csv. So that allows you to have that data set and you could create a new script and call the species summary rather than having to do all that work again. So that's another nice way of doing that. And then I left you all with some homework. So next steps, make a box plot of petal width instead of sepal length. So try to see if you can learn how to do that. Filter by just versicolor before plotting. So see what happens when you do a filter before you do a plot. and then try a scatter plot with shape instead of color. Because that's another way to deal with like color vision issues, is you're able to save things as like triangles, squares, and circles, and everyone can see the shapes, right? So that's another way to think about doing that. So I'm going to close these quickly, and we are over time. I'm sorry about that. But I'm just going to quickly show you the ICE core data set. So again, in this one, we're actually importing a real data set. So this is a lake ice core measurement from the Madison area, from the North Temperate Lakes LTER. I got it off of the Environmental Data Initiative. Okay. So I gave you the citation here, and that's how you can find this data set again. And let's say you contacted the authors and said, hey, I really want to use your data in a project. This is how you would cite that data. And they have more information about that on the Environmental Data Initiative. And you can actually just hold control and click this to go directly to the web page with this data set so you can learn more about that data. But I really just want to show you quickly. Again, this is a step-by-step on how to use this, how to load the libraries. Again, here tells you where you are. So it tells you that you're inside of the R project. And then you want to read the data by saying, okay, read CSV is the function to read data. You're looking in seeing where R can see what data it can find, and you're saying, look in the data folder and find me this file. So you do have to type this out exactly. If if you tried to run this and it didn't run, that might be an issue. But I ran it. It seems fine. Right, great. I created a data set called ICE, and then it has all of this stuff. So sample date, lake name, ICE station, station depth. Again, you can look at the actual website with the data to see the metadata and learn more about it. Blue ice, white ice, snow depth, total ice. And you'll notice that there's NAs in this data set. So there's some work in this script that teaches you how to deal with NAs, teaches you how to deal with dates, and other sorts of things. It's a relatively small data set, so I thought it was useful for doing that. So we won't run through this whole thing, but you can see that we're doing some really similar work that we did in script one. So hopefully it's all familiar to you. Just you'll be using an actual data set that people went out and collected. So thanks to those folks who collected that data so that I could help people with this illustration, and then check out that link so that you can find more stuff on Environmental Data Initiative. It's a really useful website to know about. Um, and with that, I'll go ahead and stop sharing. I know we're over time, but I am happy to try to answer a couple questions if the runners of the show are comfortable with that. If not, I'll send this to them and they can send you the R project, and you'll be able to run all this code on your own.
Hey, thanks, Josh. Thank you so much. That was really amazing. And of course, if you have time, we're happy to stay a couple more minutes or, a little longer if people want to stay tuned in and ask questions. Thank you so much. It was really helpful.
Thank
Nice
you.
introduction. I'll let people just jump in and turn in their mics on if they want to ask a question, or if you're a bit shy, maybe you can put them in the chat.
You're welcome. Ready? Is there a general recommendation for the length of code? Not really. This is going to be sort of up to the individual person. Some of it will depend on the complexity of the task. Um, so, sometimes I usually run into scripts that are somewhere between 500 and 1,000 lines, probably. Some of that is because, like you saw in the code that we used for the iris and the ice data set, I put individual arguments on their own individual lines. I think it's easier to read personally, You don't have to do that. That could shorten the code down. But I like to do that because I think it's just much easier, and I'm trying to make it friendlier, mostly for myself in the future, but also other people who might want to read my code, like a colleague or a person in the future who wants to use the data that was published. So I'm trying to make sure that's really easy to read. So usually what I do is I break things into chunks. For example, you may want to have a script that's just installing all the packages you need to run, right? So that's one script. And then your next script would be like the very basic, like turning the raw data into clean data. Like, okay, we had this raw data. It doesn't look very good. We cleaned up the column names and we did some data manipulation to like add a column for like area or add a column for, whatever. Um, and then you have that clean data, and then I'd start a new script and I'd start with the clean data, and then I'd do some basic visualizations. And then I'd start a new script and I'd do statistical analysis. It just makes it much, for me personally, it makes it much easier to follow the like breadcrumbs, basically. You can follow the steps you took so that it's much easier to recreate your data. And I mean, I've made enough mistakes of making super long data sets where I did everything in the same script, where I can't figure out what I was trying to do, why I was doing it that way. So it's much easier if you break it up into little, like, more digestible kind of chunks. Cool. Yeah, I mean, I don't want to rush people, but we are past the hour. And yeah, so when I send out the R project through Glion, the Glion email listserv, I'll go ahead and include my email, and you're welcome to ask me any questions. I'm happy to respond.
Great. Thank you so much, Joshua.
Yeah,
Well, thank you everyone also for participating. And yes, we will transfer all of the information and material to everyone. And we will also post the recording of this workshop as soon as possible on the YouTube channel and share the link with all of you. Thank you. Have a good day, everyone. See you for the next workshop, maybe. Bye.
Thanks. Bye.